Scenario: Mercury has a mass of 3.3 times 10 to the 23rd kilogram and is in an elliptical orbit around the Sun. The Sun exerts a gravitational force of 2.07 times 10 to the 22 newtons on Mercury when Mercury is at its closest point in its orbit. The centripetal acceleration of Mercury is most nearly ... So the question asks, what is the centripetal acceleration of Mercury at this point? The answer: the little g is the gravitational field, also called the acceleration of gravity, which is the centripetal acceleration of Mercury in circular motion. AC is equal to g. The force of gravity here is 2.07 times 10 to the 22 newtons. The mass is 3.3 times 10 to the 23rd kilograms. The centripetal acceleration, which is equal to g, which is equal to our question mark, that is our unknown. We can now use the force equation. Fg is equal to mass times the gravitational field. Divide the mass to both sides. You can now solve for the gravitational field. The gravitational field here is the force of gravity divided by its mass. Once you plug in all the values, you should get a value of 0.0627 meters per second squared for the gravitational field. This is the gravitational field, which is the centripetal acceleration of Mercury when it is in circular motion around the Sun. The question asked, how should the centripetal acceleration change for Mercury as it moves further away from the Sun during its orbit? Let me give you a visual to help you out. Here is the Sun. Mercury is right here in its orbit, and it has an elliptical orbit. At its closest point here, we have a g value that is approximately 0.0627 meters per second squared. Notice as it gets further away, this way, that the g here is when Mercury is at its closest point in its orbit, okay? So as it gets further away, the distance between the two objects, so Mercury and the Sun, is now larger. The force of gravity between them will now get lower because as Fg goes down, the g is going to go down, right? And the reason why the force of gravity gets lowered is because it is now further away. So the r here will increase, making the force of gravity get lower. R increase, force of gravity will decrease. As a result, since force of gravity decreased, the g will also decrease. So the centripetal acceleration of Mercury will decrease as it moves away from the Sun. At its farthest point in its orbit, the centripetal acceleration of Mercury is 0.0272 meters per second squared. These are all real numbers, and these are the real values of the centripetal acceleration of Mercury. Please note that this is in a elliptical orbit. That is the reason why there are two different values for the centripetal acceleration. One value is for when it's at its closest point, and one value is when at its furthest point. When it is a circular orbit, the r is one value, so there's only one value for the centripetal acceleration. There you go.